Hi there, and welcome back to MA 211. Let's go ahead and practice some undetermined coefficients problems. Remember, the goal when we're doing undetermined coefficients is to find one solution to the inhomogeneous differential equation that we have. We're not trying to find a general solution, we just need one solution. So, in this problem, what I want to solve is y double prime plus y prime plus y equals t squared plus t plus 1. We're going to go ahead and take a guess at a solution, yp equals, and then we take a look at the right hand side of the ODE. It's right here. It's a polynomial of degree 2. So we're going to guess that our solution is also a polynomial of degree 2. We don't know which one it is. We'll just say it's at squared plus bt plus c, and then see if we can find coefficients a, b, and c that make a solution to the ODE. So now our goal is find a, b, and c. Let's see. So what we want is a solution to this differential equation. So that means when I plug this expression into the ODE up here, I ought to have the two sides equal to each other. So let's see. If yp is at squared plus bt plus c, then yp prime would be 2at plus b, and yp double prime will be 2a. So that means that yp double prime plus yp prime plus yp would be 2a plus 2a t plus b plus at squared plus bt plus c. We would like that to be t squared plus t plus 1. And now we just go ahead and rewrite the left hand side a little bit. So what we would really like is at squared plus t times 2a plus b plus 2a plus b plus c to be equal to t squared plus t plus 1. Okay, now we can just take a look at the coefficients of each term and see what we would like. So the coefficient of t squared on the left is a. We would like that to be the same as the coefficient on the right, which is 1. The coefficient of t on the left is 2a plus b. We'd like that to be the coefficient of t on the right, which is 1. And 2a plus b plus c, we'd like that to be 1 also. So we can write that as a system of equations. We would like a to be 1, we'd like 2a plus b to be 1, and we'd like 2a plus b plus c to be 1. So we can see that b has to be -1, c has to be 0. By the way, it's okay to use Maple to solve these systems of equations. And we can get our general solution. Now we have a, b, and c that give us a solution to the differential equation. So we can say yp is t squared minus t plus 0. And that's it. There is one solution, our particular solution to the ordinary differential equation. Alright, let's go ahead and try another problem. In this problem, I would like y double prime plus y prime plus y to be e to the minus 3t. Again, we're looking for just one solution, yp. We'll take a look at the right hand side of the ODE and say, aha, it's an exponential function with coefficient -3, so we'll guess that our solution is also an exponential function with coefficient -3. So we'll guess that yp is a times e to the minus 3t. What we want to do, again, we want to plug this yp into the right or into the left hand side of the ODE and see what that says about what a would have to be. So let's see, I want, if I calculate yp prime, that'll be -3a e to the minus 3t, and yp double prime would then be 9a e to the minus 3t. If we plug those into the left-hand side of the differential equation, we'd get 9a e to the minus 3t minus 3a e to the minus 3t plus a e to the minus 3t. We would like that to be equal to e to the minus 3t. Well, we can collect the left-hand side and get 7a e to the minus 3t. We'd still like that to be e to the minus 3t. So we can see that a is going to have to be 1/7. And that means we have one solution to the ODE that is 1/7 e to the minus 3t. Okay. In this problem, I think I better start a new PDF. I might not have enough room to do this problem in the little bit of space that I have. So I would like y double prime plus y prime plus y to be equal to, let me check, sine 4t plus e to the 4t plus t cubed. Alright, once again we'll take a guess at what our solution looks like. We'll guess that yp is equal to, and now we have sort of distinct terms on the right hand side. So corresponding to the sine 4t term, we'll guess that yp has terms a cosine 4t plus b sine 4t plus, corresponding to the e to the 4t term, we'll guess that there is a c e to the 4t in our solution. And corresponding to the t cubed term, we'll guess that there is a dt cubed plus, I don't really like to use e as a coefficient, so I'll skip it and go to ft squared plus gt plus h. Alright, and now this proceeds just the same as all the other problems. I need to take this guess, plug it into the left-hand side of my ODE, and see what that says about my coefficients. What do those coefficients have to be to make that left-hand side equal the right-hand side of the ODE? Well, yp prime would therefore be negative 4a sine 4t plus 4b cosine 4t plus 4c e to the 4t plus 3dt squared plus 2ft plus g. Yp double prime would be negative 16a cosine 4t plus 16b sine 4t plus 16c e to the 4t plus 6dt plus 2f. So we can plug those into the left-hand side. We'll calculate yp double prime plus yp prime plus y plus yp, and we'll see what we have. We'll go ahead and I'll group things all at once here. So we'll have, if I add up yp double prime plus yp prime plus yp, I'll have cosine 4t times negative 16a minus or plus 4b plus a. I'll have a sine 4t times, try not to mind my dogs there, sorry. I'll have a b minus 4a plus 16b. I'll have an e to the 4t term times 16c plus 4c plus c. I'll have a t cubed term with a d on it. I'll have a t squared term with f plus 3d on it. I'll have a t term with g plus 2f plus 6d on it. And I'll have a constant term of h plus g plus 2f. And now what would I like that to be equal to? I'd like that to be equal to sine 4t plus e to the 4t plus t cubed. And once again, we can just equate coefficients here. Let's see. The sine 4t term, I would like its coefficient to be 1. The e to the 4t term, its coefficient needs to be 1. The t cubed term, the coefficient needs to be 1. And all the other coefficients need to be 0. So we can rewrite this as a system of equations. This first term we can rewrite as, what can I rewrite that as? Negative 15a plus 4b. I'd like to be 0. I would like negative 4a plus 17b. That's the coefficient on sine. I want that to be 1. I want, let's see, that left-hand side is 21c. That's the coefficient on e to the 4t. I want that to be 1. I want the coefficient of t cubed, which is just d, to be 1. The coefficient of t squared is f plus 3d. So I want f plus 3d to be 0. I want the coefficient on t, which is g plus 2f plus 6d, to be 0. And I want the constant term to be 0. So that's h plus g plus 2f. Now something like this, well, actually you could do this by hand, but just go ahead and use Maple. If you do that, you'll find that a needs to be negative 15 over 241. B needs to be negative 4 over 241. C needs to be 1 over 21. D needs to be 1. F needs to be negative 3. G has to be 0, and H has to be 6. So if you plug those back in, these coefficients, you can get one solution to the ODE is yp equals, let me just check, a was the coefficient of cosine, okay, so negative 15 over 241 cosine 4t minus 4 over 241 sine 4t plus 1 over 21 e to the 4t plus t cubed minus 3t squared, no t term, plus 6. And there you have one solution to the ODE. Okay, so for the rest of these problems, I'm going to skip, sorry about that, I'm going to skip actually solving the problem. I'm just going to walk through what the correct guess is. After you have the correct guess, there's nothing really to it. You plug everything in, you calculate the derivatives, you group terms, and you solve. It's the same every time. So in this problem, I want yp double prime plus yp prime plus yp. I would like that to be t e to the 2t. The corresponding guess here we have a polynomial times an exponential. And just like they do in the book, we'll take a guess that our particular solution is a polynomial of matching degree, so at plus b times a corresponding exponential, e to the 2t. Once you have this guess, you calculate derivatives, plug everything in, everything goes as normal. Here, our guess should be, here we have an exponential, here we have a trig polynomial. So our guess should be, let's see, an a cosine 2t plus b sine 2t times your exponential, e to the minus t. Here we have a sum of things, polynomial, well, sine term, here you have an exponential, cosine term, so your corresponding guess will be yp. Corresponding to the first term, you'll have a polynomial. Well, you'll have every term, every power of t here multiplied by both sine and cosine. So you'll have at squared sine 3t plus bt sine 3t plus c sine 3t. Plus, and then you'll have corresponding terms with the cosines. So you'd have dt squared cosine 3t plus ft cosine 3t plus g cosine 3t plus, and now you have the other term to worry about. You'll have an e to the minus t times, let me see, h cosine 4t plus, I really don't like using I as a coefficient, I'll skip to j, sine 4t. And that's it. There's your guess. And from here you could get a particular solution to the ODE. Now, I'm going to warn you, on quizzes or on an exam, I might well ask you to find the form of a particular solution to the ODE. When I say that, I mean this. I don't want you to go ahead and find a particular solution. I'm saying just give me the initial guess, and I often will call that the form of a particular solution. Don't be surprised when I do it. This is what I mean. Just give me this guess with the coefficients in there. Don't go on and solve the ODE. So that's it.